This is grade 8, lesson 4, video 3. This is just the answers for page 4 to 12. Alright, so in the last video I asked you to do exercise 1. We did 1.1 together. 1.2, please mark your work. If you send me a link in a private chat in Teams, I can send you a PDF version of this memo. So 1.2 should have got 168 centimeters cubed. Please make sure that for every single one, I know it's a lot to do every single time, but you need to write down your formula, then your substitution, and then your answer, and make sure you've also got units. If you leave out any one of those 4 parts, you will lose marks. So when we mark this, you get a mark for your answer. So you get a mark for your formula, a mark for substituting the correct values, and a mark for your answer with the correct units. Please don't forget any of those steps. Okay, 1.3 should have got 125 centimeters cubed. 1.4, 80 centimeters cubed. 1.5, 54 centimeters cubed. And 1.6, you should have got 105 centimeters cubed. 1.8, 1,610 centimeters cubed. 1.9, you may have got your answer in scientific notation. If you did, then your answer for that would have been 5,12 times 10 to the 5 centimeters cubed. 5,12 times 10 to the 5 centimeters cubed. That would have been perfect as well. So notice there was a conversion over here. You first had to convert 0.8 meters into centimeters, because the original question, if you look back at the top, the original question did say, please write your answer in centimeters cubed. So that's why. Alright, and so if you convert 0.8 meters into centimeters, you're going from a big unit, meters, to a smaller unit, centimeters. So you need to divide by, we need to multiply if you're going from big to small. Big to small. So meters to centimeters, you would need to multiply by 100. So 0.8 times 100 would give us 80 centimeters. And obviously if the cube, then you're going to have 80 by 80 by 80. That gives us 5,12 times 10 to the 5 centimeters cubed. And if it's got a square base, then that means that the length is equal to the breadth. So we've got 20 centimeters, 20 centimeters, and its height. Its height then would be 8 centimeters. Okay, that should give you your answer of 3,200 centimeters cubed. 2.1, now we have to actually calculate density. So for 2.1 we've got a block. Its mass is 54 grams. So mass 54 grams. And volume 27 centimeters cubed. So 54 divided by 27 gives us 2 grams per centimeter cubed. Maybe a good idea to write it with 2 decimals. Okay. Question 2.2, 100 grams, 55 centimeters cubed, gives you 1,82 grams per centimeter cubed as your volume. The rest shouldn't be too bad. Let's have a look at 2.6. Asked to calculate the density of a block with the following measurements. So they gave us mass of 180. And the measurements of the box were 10 by 2 by 3. So first you have to calculate the volume. Once you've got your volume of 60, then you take that 60 and substitute it in place of your volume in your density formula. So the 180 grams divided by 60 centimeter cubed gives us 3 grams per centimeter cubed. Similar thing for 2.7, first calculate the volume, and once you've got the volume, then you would need to work out the density. But for 2.7, they gave us mixed matched units. So they gave us these units of centimeters, but then they gave us this in kilograms. So if you've got units of centimeters cubed, then you should have density in grams per centimeter cubed. So that means that your mass must be in grams. If you're dealing with volume in meters cubed, let me just write that down for you. So grams per centimeter cubed, that's one option for you to have. Or you can have kilograms as your unit for mass and meters cubed as your volume. So either of these, but you can't mix match them. You can't have kilograms, for example. You cannot have kilograms per centimeter cubed. That would be wrong. Alright, so because you've got centimeters cubed and kilograms, you need to convert either the centimeters to meters or the kilograms to grams. Let's convert kilograms to grams. So kilo means times 1,000, so 16,2 times 1,000 will give us 16,200 grams. So you need to do that conversion first for 2.7. There we go. There's your conversion. So once you've got grams and centimeters cubed, then it's quite easy. Take your mass in grams and your volume in centimeters cubed, and that'll give you an answer in grams per centimeter cubed. 2.8. There they gave us the density and you had to calculate its mass. So for that you needed to rearrange your density formula. So normally density is mass per unit volume. If you rearrange it though, mass is equal to density times volume. And they gave us that the density was 5 grams per centimeter cubed. The volume was 20 centimeters cubed. So you just have to sub those in and you'll be able to work out the mass of the substance. Okay, this one I'll go through with you as well. So we've got Saheti students that are arguing about the type of material that's used to make a metallic rectangular block. We've got its mass, 1,080 grams, and there's its measurements. Please make sure that you change your height from 20 millimeters, because originally your book said 20 millimeters. And you need to change that millimeters to centimeters. There was a mistake in your notes. Please change that. Okay, so let's first work out the volume. So we're going to take the 10, the 2, and the 20, and that gives us a volume of 400 centimeters cubed. They said that its mass was 1,080 grams. So that's its mass, and 1,080 divided by 400 gives us a density of 2,7 grams per centimeter cubed. Now we have to go up to this table and see which of these densities match up with 2,7. Once you've done that, you'll see that it is in fact aluminium. It's got a density of 2,7. So the block's made from aluminium. Quite a cool way to identify a substance. Okay. What is the mass of a block of gold with the same measurements as the previous question? So the same measurements, that implies that the length would be 10, the breadth 2, and the height 20. So that's what we mean by same measurements. But now, if we're dealing with gold, gold has got a density of, let's go down our table, gold's got a density of 19,3. So you're going to sub in 19,3 in place of your density. Use the same volume as 400, and then I'll give you that the mass of gold would weigh 7,720 grams, whereas the aluminium was only 1,080 grams. Okay, here's the instructions for calculating the density of the rock. Again, if you need this, I can send it to you in PDF. And here's the other method. again, this is the example. Please make sure that you have all of your calculations. So final volume minus initial volume. Work out what the volume of water is that would be displaced by that stone, and the stone's mass comes out to be 84 grams. For the next lesson, please have a read through Sink or Float, and also a good idea to watch these videos that are in your notes. And that's all. I will upload the next videos on Tuesday or Wednesday. Thanks, Gr8.